Hey everybody, this is Larry. This is something that I haven't done in a while. It is March 6th in the year 2025, which is to do a problem that I haven't done before. I'm going to do a medium today just to kind of warm myself up, and it's going to be one that I haven't done before. Apparently, I still have 600 prompts here to go in here on the right side, 650, so we have plenty of time. So let's pick a random one and let's go. Okay, I guess I should have taken out the SQL statements. I don't want to do SQL. I mean, I probably could figure this one out, but I don't want to do SQL statements. So, SQL questions. So yeah, let's try again. To do, how do I get rid of SQL statements? Oh, algo. Okay, there you go. Let's go. RNG. All right, let's go. Today we have 1135 connecting cities with minimum cost, a premium problem. There are n cities from 1 to n, so one index is given n in a way to cost, and bidirectional, okay, minimum cost, connect all city. I mean, this is just minimum spanning tree, right? Is there anything funky about it? Okay, so you have this one, you can connect all of them, so okay. But I mean, yeah, this is a minimum spanning tree problem. I don't know that there's anything that makes it even confusing to identify as such. It's just you have a lot of nodes. You want the minimum cost. Well, I mean, you know, and part of the minimum spanning tree proof is greedy, and the minimum cost is going to be when you just connect all of them once, right? And you could, yeah, even without greedy, you could probably reason it. Like if you have two paths going from one place to another, then it is not minimum cost because you could get rid of one of them, right? So anyway, yeah. So yeah, I mean, I think in terms of theory, this is pretty straightforward. I know that a lot of people nowadays might have a template for it, but I'm going to try to do it from scratch, and we'll see. What is n? N is 10 to the 4th, so we have to be a little bit better. Yeah, and what I mean by better is that you can do an n squared prime of prims. Sorry, not primes. Prims, but yeah, we can use Questro. Yeah, what does I do with Questro? Oh, it's just sorting the edges, right? Okay, yeah. So then. And honestly, as you can tell, I'm a little bit rusty, and I haven't even thought about it. But these things are not that bad. It's just you just have to do them right. So here we want to sort by connection. We want to sort where key of x is going to be. We just sort by the third element. Really. That's it. And now you have for U, V, and wait for W. Then in connections, of course, we want to also do whatchamacallit, union find. Sorry, I am not in shape. Yeah, so we want to do union find, so we could type that out. So parent is equal to x for x in range sub n. What I'm pausing on is just whether I should do it 0 index and 1 index. I know that the input is 1 index. We could convert to that though, so no problem. So yeah, so here we just have two functions, union find and find. So if parent sub x is equal to x, or if right. And this is path compression. I'm not going to go over it in this video just because, I don't know, I mean, you can probably do it in anywhere, right? Like you could find, so I'm typing, you could find union find readers all over the place, and Costco and minimum span readers. It's all sorts of videos, academic and not, so I'm not going to spend that much time on this one. So yeah, but now that this is sorted, we can just do, yeah. I guess we can do some stuff so that we don't do it twice, right? So here we can say if UA is not equal to UB, then we want to merge, and then we just return true, return false. So then, yeah, as you can see, I have like some mental template, and we can make changes to what we need, right? So then total cost is going to be equal to 0, right? And maybe count of the edges is also equal to 0, right? So yeah, we want to make it 0 indexed. So we do UV, right? So if this is true, then we have a new edge. So count increment by 1 and total increment by the weight. And that's it, right? So we return total in theory, but you know, we have to make sure that count is equal to if count is equal to n minus 1, because that's the number of times we should have added. Then if this is not equal to that, we return -1, right? And that should be it. Hopefully no too silliness. Apparently I did make some silliness. We have 3 nodes, we add 2 edges, right? Oh, this is dumb. I mean, I am dumb. We can make modifications, but you should make sure that they're the correct modification. So if this is true, then we return true, but we want to set this anyway. So if this, I think I messed up the order in my head, that's why. So if they're equal, then we just return false, and then, yeah, all right, that's a little bit cleaner, and also a little bit more corrector. So yeah, pretty straightforward, honestly. I'm a little bit rusty, as you can tell, but still not that much of an issue. Yeah. Let me make it slightly smaller so you can maybe see all of this on screen. Roughly good enough. But yeah, this is union fine, right? The sorting is going to dominate the sorting of the connections. It's going to be, I want to say n log n. Well, actually, no. I forget that they're given number of connections, right? So you have V and Y, where V is the number of vertices and Y is the number of edges. This is Y log Y just due to the sorting, right? Yeah, E log E due to the sorting, and everything else is, let's just say roughly speaking, this is all of 1 for reasons that, you know, I'm not gonna go into. I know some, you know, inverse argument, etc. But yeah, so then as a result, it gets dominated by n log n in either case, because whatever this is, as long as it's not log n, it's not gonna be dominating. So this is did I say n log n? I mean E log E, which is n in this case anyway. I mean, I know this n, which is confusing, but n is actually the size of the input, and the size of the input log n, right? N log n. Anyway, that is all I have for this one. Let me know what you think. Thanks for watching, and yeah, stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye bye.